In today's video, we're going to continue our discussion of basic concepts in quantitative research, and we're going to talk about something that you might find slightly strange. I'm sure that you all have the idea in your mind that you actually know what a number actually is. So let's start, and I'd like you to take a few seconds to jot down a few notes on what you think is a number. So what for you is a number? Of course, this issue is going to be central for any approach to quantitative research, because quantitative research at the end of the day deals with quantities, deals with numbers. So take a few seconds and jot down your thoughts on what is a number. Okay, now let's deal with some common perceptions of numbers. I think the most common perception is to think of numbers as counting machines. You have one thing, you have one other thing. If you put them together, you have two things. So one represents a single entity, two represents two things together, and allows you to characterize what your counting looks like. But this is the thing, numbers are not essentially natural. Quantities are natural, but numbers are not essentially natural. They are basically concepts, they're symbolic concepts that we use in order to represent quantities. And then we use these concepts and we apply them to the world, and it's very, very helpful. It's helpful to know that I have two things or four things or five things in the world. There's something else about numbers that's worth paying attention to. Numbers are part of a logical thinking system. They are, in actual fact, a logical thinking system. And because they're a thinking system, we have a range of conventionalized guidelines for how to work within that systematic logical system. So what's within the logic of the system works according to the logic of the system. So if you look at the scale that we have below, you'll notice that the distance between 0 to 1 and the distance between -1 to 0 is the same distance. That is a logical thinking guideline which allows us to make certain assumptions about -1 and +1 and how far away they are from the number 0. And the same is true of -5 to +5. So before we move forward, just bear in mind that we are talking about a conventionalized set of understandings working within a logical thinking system, which allows us to handle the idea of quantities. Okay, now I asked up front in the first slide what you thought a number is. And actually what I should have said, what are numbers, or what are the different understandings we have of numbers, because numbers actually have different uses. And we're now going to talk about four different types of use of numbers. As I'll say at the very end of this lecture, this is important because the type of statistical approach we take depends in part upon the type of number that we're dealing with. Okay, so let's deal with the first type of number as a label. So in this case, the number is not really a number. It's a sort of name for a semantic quality. So if you've ever phoned up or used any sort of electronic system where you phone up and they say press 1 for English, press 2 for Arabic. 1 and 2 are numbers, but they're not working as counting systems, right? They're just names for a particular category of information. I can give you another example. I live in a house which is 6311. The house next to me is 6331. There's no particular reason for that. There's no building in between us. It's not consecutive in any way. It's just apparently that's what happened somewhere along the way, because it's a name of a place. It's not actually a number in the usual sense. It's number as a label. Okay, now let's look at a second usage of numbers, and I think this gets closer to what most people think of and understand as numbers, and that is numbers as an ordering system. So there are many situations in which we want to order the presence of things. So for instance, take a race. Joan came in first and Joel was second. So there is an order here, first place and second place. We don't actually know how much quicker Joan was than Joel in this particular example, but we do know that one came in first and one came in second. So we can use numbers to designate the position in relation to other objects or other things. So come in first, come in second, come in third. This, I think, the third usage is what is most commonly understood as a number, and that's number as a counting system. Now, it's important that we're talking about counting distinguishable objects and whole objects, I would say. So there were 5 chocolates in the box this morning, and now there are 3. Who ate them? So I have 5 chocolates. I had 5 chocolates. Now I have 3 chocolates. So the numbers here are used to quantify the number of distinguishable objects that I'm actually looking at. It's important to note once again that numbers as counting systems is when we're talking about discrete objects, objects that are distinguishable from one another. And the final usage of numbers is as what I would call measurement, or as a measurement system. This is when you use numbers to quantify continuous qualities and characteristics of objects in the world. Now, I'll explain that slightly. Continuous means that you could divide into an infinite number of divisions between one object and the other, between one point and another. So instead of eating, for instance, 5 chocolates, you ate 5.5 chocolates. So that's already we're moving into a continuous system. Now, you can say your temperature is 98.6. So you've divided it up. So you have a very exact type of measurement that you could make more and more exact, because between 1 and 2, there's an infinite number of divisions you could make, 1.11111, 1.11112, and so on and so forth. So basically, we have 4 uses of numbers: as labels, as an ordering system, as a counting system for discrete objects, and as measurement, which is a counting system with a continuous range of numbers. Now, in data analysis, when we actually get to the point of data analysis, we're going to talk about 3 types of scales. In actual fact, there are 4 types of scales. There's also a ratio scale, but it's not important for our current course. So let's talk about the 3 types of scales that we are going to use in quite a lot of detail as we move forward to the course. So the first type of scale is called a nominal scale. And the nominal scale, as the name implies, nominal meaning naming, nominal scales are used when we have numbers as labels. So we can count how many people, we can designate Arabic as a language as number 1, Mandarin Chinese as number 2, and so on. So nominal scales just name something, and we have certain ways and approaches of analyzing that type of data. The second type of scale we have is ordinal scales, and this is number as ordering systems. So they show rank order: first, second, third, fourth, fifth, and so on. And finally, we have what are known as interval scales. And interval scales are real numbers with difference on intervals between different points along the way. They are measurable and they are meaningful. Whether they're counting systems, whether they are continuous or discrete, we can use them in particular ways. Now, these 3 types of levels of data also have different properties that are worth thinking about. You'll notice as we go down this list that as the higher up you go in the level of measurement, you include all the previous qualities of the lower levels. So you can always go down a level when we do analysis, but you cannot go up because you do not have the same properties. So when we have nominal data, remember things like gender or language base, each one of the items is distinct, and basically all nominal data tells you is that one is different from two. Arabic is different from English. Male is different from female. It's only an issue of distinction. In ordinal data, you still maintain the distinct properties. So you still know one is different from two, right? First from second. But you also know which one is larger or which one is positioned higher than the other one. So first comes before second. And with interval data, you still maintain the distinct and the ordering, but you also have an important characteristic of equal intervals, and therefore you can say how much larger or how much faster was one from two. So the number actually tells you not that it's just first or that it's larger. It tells you exactly how much larger it is because the measurement system has equal intervals. Okay, and that's a very brief introduction into different types of numbers and what they do. Why is this important? Well, very simply put, nominal, ordinal, and interval data require different types of statistical approach. When we talk about how to analyze data, one of the first things we're going to consider is what type of data are we actually talking about? What data did I collect? If I collect nominal data or ordinal data or interval data, that is going to direct me to a particular type of approach and test that will be used to evaluate that data. This is a core and basic component of all statistical analysis. For our analysis to be meaningful, we need to understand what the data actually consists of, and that will tell us what we actually need to do. I hope this introduction has been useful for you, and we'll be developing these ideas as we move forward.